Hello, my P number is P2865078 and thank you for joining my presentation on Northvolt AV, an European pioneer in sustainable battery manufacturing. This presentation has been developed as part of my assessment for the Global Operations and Supply Chain Management module. Over the next 60 minutes, I will be analyzing Northvolt's supply chain through the lens of the Supply Chain Operations Reference Model or SCORE to understand its strengths, weaknesses, and opportunities for improvement. The aim is to show how the SCORE framework helps in systematically diagnosing and enhancing supply chain performance, from planning and sourcing all the way to delivery, returns, and enabling processes. I will also use analytical tools like Pareto analysis and a fishbone diagram to identify key challenges and their root causes. Now let's begin with a brief background about Northvolt and its industry context. Northvolt AV was founded in 2016 in Stockholm by two former Tesla executives, Peter Carlson and Paolo Chiruti, with a bold mission to build the world's greenest battery with minimal carbon footprint. The company produces lithium-ion batteries primarily for electric vehicles, energy storage systems, and industrial applications. Its main facilities include Northvolt ETT in Skellefteå, Sweden, which is its first gigafactory, Northvolt Labs in Bastures for R&D, and the Revolt Recycling Facility, which processes used batteries and scrap materials to recover nickel, cobalt, and lithium for reuse. Now, looking at the broader industry overview, according to Statista 2025, the global lithium-ion battery market was valued at approximately $73.6 billion in 2024 and is forecasted to reach $186 billion by 2030, growing at a compound annual rate of about 16%. Europe is a key growth region due to its ambitious Green Deal policies, electric vehicle adoption targets, and energy storage requirements for renewable power grids. According to Euromonitor International 2024, key competitors in this space include CATL in China, LG Energy Solution in South Korea, Panasonic in Japan, BYD, and Samsung SDI. These companies have well-established production bases and strong R&D capacities, making competition intense. However, what differentiates Northvolt is its closed-loop, low-carbon supply chain. It sources renewable energy for manufacturing and aims for 50% recycled material content in its batteries by 2030. Northvolt's major clients include BMW, Volkswagen, Volvo, and Scania. These automakers depend on Northvolt for sustainable, traceable battery supply to meet their carbon neutrality targets. Hence, an efficient supply chain is not only a business necessity, it's central to Northvolt's value proposition and brand identity. To evaluate Northvolt's operations, I will be using the SCORE model, which stands for Supply Chain Operations Reference, developed by the Apex Supply Chain Council 2017. SCORE is an internationally recognized framework for assessing supply chain performance. It provides a standardized language and structure for describing how materials, information, and financial flows move across organizations. The SCORE model includes six main processes. Number 1. Plan. Activities related to balancing demand and supply. Number 2. Source. Procuring goods and services to meet planned or actual demand. Number 3. Make. Transforming materials into finished products. Number 4. Deliver. Managing orders, logistics, and distribution. Number 5. Return. Handling product returns and recycling. And at last, number 6. Enable. The supporting infrastructure like IT system, HR, and finance. According to Hafiz, the SCORE model helps organizations improve agility, and responsiveness by integrating metrics, best practices, and performance indicators. Similarly, Kasi highlights that SCORE enables benchmarking against competitors and facilitates continuous improvement by linking process performance to business results. In short, SCORE helps us systematically dissect North Pole's supply chain, identifying where value is created and inefficiencies exist. Let's apply SCORE to North Pole's real-world operations. Plan. North Pole forecast demand based on automotive OEM contracts and expected EV sales growth. It uses predictive analytics to plan factory output and material procurement. However, as seen during 2023, volatility in global EV demand and material prices often leads to overproduction or underutilization. Source: the company sources lithium from Australia, nickel from Finland, and cobalt from ethically certified suppliers in Africa. However, geopolitical risks and transport costs make sourcing vulnerable. Make: manufacturing at North Pole ETT is powered by renewable hydroelectric energy. The production process is highly automated and designed for circularity. Scrap material is recycled via its Revolt facility. Deliver: batteries are shipped across Europe using road, rail, and sea transport. North Pole aims to reduce delivery emissions by partnering with low-carbon logistics providers. Return: the Revolt program focuses on recycling used batteries and recovering up to 95% of valuable metals. Enable: ERP systems, digital twins, and data analytics platforms enable end-to-end visibility and coordination. Through this mapping, we can see that SCORE helps structure North Pole's supply chain into a logical, interconnected set of processes that support sustainability and operational efficiency. Now let's move on to the next slide. Let's dive deeper into two of the most critical SCORE processes for North Pole, which is plan and make. Under plan, North Pole integrates customer demand forecast with capacity and material planning. However, forecasting accuracy remains a challenge. Fluctuation in EV market demand and supply constraints for raw materials often lead to a mismatch between plan and execution. The company uses scenario planning and AI-driven forecasting, but limited historical data and volatile energy markets introduce uncertainty. Under make, production capacity at North Pole ETT is planned to reach 60 GWh annually by 2026. The factory relies heavily on automation and renewable energy. While Lean Six Sigma principles are applied to minimize waste and defects, challenges remain in balancing sustainability and efficiency. As Slack explained, bottlenecks can arise when energy interruptions or machine downtime reduce throughput. By examining both plan and make processes together, it's clear that forecasting errors upstream often propagate downstream, affecting production stability and delivery performance. From North Pole's case and complaint data, one major operational challenge is frequent production and delivery delays. Using the is or is not framework, we can describe it more precisely. It is a recurring issue in the manufacturing and sourcing stages. It is linked to supplier dependency and energy supply volatility. It is not due to design flaws or workforce shortages. It is observed at the North Pole ETT and North Pole DWA plants. It is not observed in the reworld recycling operations. This indicates the root cause lies in upstream processes, namely sourcing and production planning, rather than in after-sales or customer service. Such problems directly impact delivery reliability, increase lead times, and reduce customer satisfaction. Identifying and prioritizing these issues is the foundation for improvement. To quantify the complaints, I conducted a Pareto analysis based on the Excel data provided. After grouping over 200 complaint records and summing the complaint days per category, the analysis revealed that just four main categories contribute to around 80% of total disruptions. These are in-house production limitations, supply chain dependency risk, carbon reduction initiatives delayed, and crisis response inefficiencies. This follow the 80-20 principle, which means 20% of causes lead to 80% of effects. In practical terms, Northvolt can significantly improve performance by focusing on a new critical areas rather than trying to solve everything simultaneously. The Pareto chart shows that issues in the source and make stages dominate. These findings aligns perfectly with a scored diagnostic framework where supplier reliability and production efficiency are often the key determinants of success. The fishbone diagram helps visualize the root causes of supply chain disruptions. At the head of the fish, we have the main problem, frequent supply chain disruptions and frequent supply chain disruptions leading to delays and production gaps. Now let's walk through its main category aligned to the SCORE model plan. The causes include poor demand forecasting, inadequate risk assessment, and limited scenario planning. Rapid EV market shifts and geopolitical factors make long-term planning difficult. Source: dependency on Asian suppliers, raw material shortages, and volatile global prices cause procurement delays. As Rain notes, supplier diversification is essential for risk mitigation in global supply chains. Make: this involves manufacturing efficiencies and battery cell defects, limited automation in newer plants, and occasional energy supply interruptions. Deliver: transport bottlenecks, customs delays, and a lack of diversified logistics partners increase lead times. Return: recycling systems are still developing, and recovery rates, while impressive, have room to improve. Enable: issues include a shortage of skilled engineers, fragmented digital systems, and limited interdepartmental coordination. From this diagram, we can clearly see that most root causes fall under source and make echoing our Pareto findings. Now let's move to the last slide. To address these issues, I propose several strategic improvements aligned with the SCORE model. Plan: adopt an AI integrated forecasting system that uses live EV market data and energy prices to dynamically update demand plans. This will enhance responsiveness to fluctuations. Source: expand regional supplier networks across Europe and invest in long-term partnerships with ethical mining firms. Increase recycling inputs to reduce dependency on virgin raw materials. Make: strengthen energy resilience by installing on-site solar and wind capacity. Implement predictive maintenance tools using LOT sensors to reduce equipment downtime. Deliver: build strategic alliances with multimodal logistics providers, integrating rail and sea transport to cut emissions and lead time. Return: develop smart reverse logistics using barcoding and tracking for battery returns to enhance recycling efficiency. Enable: invest in workforce training and implement blockchain technology for end-to-end traceability and quality assurance. According to Northvolt's 2025 sustainability report, these initiatives could reduce lead times by 20%, lower supply risk exposure by 15%, and cut CO2 emissions by 30% by 2030. Such score-based improvements combine efficiency, resilience, and sustainability, aligning perfectly with both business and environmental objectives. Now, it's time to conclude, and I like to conclude by saying North supply chain represents an ambitious model for Europe's clean energy transition. By applying the SCORE framework, we have seen how structured analysis helps identify both operational strengths and weaknesses, from predictive planning to ethical sourcing and circular manufacturing. Through Pareto and Fishbone analysis, we have pinpointed the most critical issues: supplier dependency, energy volatility, and production limitations, which together account for most disruptions. By implementing the proposed score-based improvements, Northvolt can enhance its operational resilience, meet growing European EV demand, and continue to lead in sustainable battery manufacturing.